Welcome to this explainer. Look, if you've been anywhere near the software engineering space lately, you have definitely heard the hype around vibe coding. And hey, it sounds incredibly fun, right? Effortlessly generating entire apps with just a few prompts over a weekend. But today we're taking all that blind enthusiasm, setting it aside, and replacing it with a highly disciplined, evidence-based approach. Based on the insights of Sriram Gopalan, this is Rightcoding: Where to Trust AI and Where to Stay Skeptical, Part 1. We are going to move past the shiny marketing and learn how to actually build software that doesn't just immediately collapse in production.
All right, let's kick things off with a little tale of two developers. They're at companies of the exact same size, and they're using the exact same AI tool. Both of them are totally all in on AI, but their execution, radically different. Now, developer A, they treat the AI like a super fast typist handing over a rough first draft. They are in there rigorously verifying business logic line by line, keeping a totally clean code base. Then you have developer B. Developer B is trusting the AI with massive architectural decisions, skimming pull requests just because the automated tests happen to pass, and shipping incredibly fast. And honestly, their demos look amazing. But let's jump ahead about 9 months. Developer A has a stable, extensible, solid system. Developer B, they are up at 3 a.m., sweating, trying to debug a massive production incident caused by an AI-generated security vulnerability that literally nobody on the team fully understands. Two radically different outcomes, driven entirely by discipline.
So, to avoid developer B's fate, here is our game plan for this explainer today. First, we'll look at what the research actually says. Then, we'll dive into the rule of right coding, figure out how to navigate the trust gradient, and finally wrap up with where humans remain absolutely irreplaceable.
Okay, part 1. What the research actually says.
We really need to cut through the tech marketing fluff and ground our approach in actual hard data. And surprisingly, on small, tightly scoped tasks, AI actually performs wonderfully. Look at this, 53%. GitHub's own controlled data shows that code written with Copilot is 53% more likely to pass all unit tests. It's even rated slightly better on readability. When we isolate the AI down to simple method generation tasks, the best assistants out there can produce fully correct methods about a third of the time. So for a first draft on a completely isolated function, these models are genuinely fantastic.
But, and this is a massive but, when you zoom out to the scale of real-world pull requests, that rosy picture completely shatters. An analysis of real PRs found that AI-assisted code contains 1.7 times more significant defects, and the security vulnerabilities, those are 1.56 times more frequent compared to purely human-written code. Logical errors completely spike too. Basically, the moment the scale and context of the task change, the AI entirely loses the plot.
And honestly, it gets even more concerning. A massive GitHub empirical study found that over 15% of AI-related commits introduce at least one issue. And here is the real kicker: nearly a quarter of those issues were still sitting there in the latest version of the codebase. This creates this sort of long-lived maintenance debt. It's the code slop that you will never, ever see in those flashy social media demos.
Even more alarming is the security data. When you ask an AI model to go in and fix human-written code, the revised versions they spit out often contain more vulnerabilities than the original snippets. They wildly violate basic secure coding practices. So if your team strategy is simply, oh, we'll just have the AI patch it later, you need to rethink that immediately. That is a total recipe for disaster.
Let's move on to Section 2, the rule of right coding. This perfectly diagnoses the current state of AI coding. AI is highly reliable at the local, syntactic level, but fundamentally unreliable at the global, semantic, and adversarial level. The entire discipline of right coding is knowing exactly which context you are operating in at any given moment. This is the exact mental model developer A had and developer B lacked. Syntax, trust the AI. Semantics, trust yourself. Which brings us to Section 3, navigating the trust gradient. So how do we actually apply this day to day? Well, we start at level 1 of the trust gradient, which is trust freely. Think about generating basic CRUD boilerplate, setting up test scaffolding, writing documentation from code you already intimately understand, or maybe just asking it for 3 different ways to structure a loop. Because these tasks are purely local and syntactic, the blast radius of an AI error here is tiny and it's immediately visible to you.
Stepping down a notch, we hit level 2, trust but verify. This is where AI output is usually pretty good, but it requires a deliberate, focused read. We're talking single-function logic without major security implications, data transformation pipelines, and unit tests.
Now, with unit tests, you really have to check the assertions carefully. AI will frequently test the wrong behavior entirely, meaning a test might happily pass when it absolutely should fail. The golden rule here? Always verify the AI's output against your external spec, your own understanding of the goal, and never against the AI's own circular logic. Okay, now we're stepping into some dangerous territory with Level 3, Treat as First Draft. When you hit multi-file changes, complex business logic with lots of conditional branching, database queries, or any code that handles user input, the AI is merely giving you a rough starting point. Remember that study showing about a third correctness on isolated functions? Well, when the task requires cross-module reasoning, that correctness literally plummets to roughly 15%. The AI models will fail quietly here. You have to treat this strictly as a rough first draft that requires some heavy manual editing.
And finally, rock bottom of the gradient, level 4, do not trust without a deep audit. These are the catastrophic danger zones. We're talking authentication flows, session management, cryptography, payment logic, and yes, even CI/CD configurations. Left to their own devices, models will actually default toward unsecure implementations and weak cryptographic primitives. In these areas, looks right is absolutely unacceptable. A line-by-line security audit, independent review, and actual threat modeling are 100% mandatory. Please do not let the machine ship this blind.
That leads perfectly into Section 4, where humans remain irreplaceable.
Knowing exactly where the AI fails is great because it highlights exactly why you are still here adding value. Current models simply cannot provide the human judgment required for complex architectural decisions. Sure, an AI can spit out a list of architectural options for you, but evaluating which of those options actually fits your company's specific constraints and future direction, or diagnosing a messy production incident across distributed systems, or figuring out the root cause of a performance bottleneck in your unique infrastructure. Context is king, and right now, you are the only one holding that context.
So as you start building out your own mental model for Rightcoding and taking on Developer A's disciplined approach, I want to pose this question to you. Where do you draw the line? Have you developed your own intuitions about where these tools completely fall apart? Drop your personal AI boundaries and your own do not trust list in the comments below. I'd love to read through them.
This framework helps a ton, but obviously it doesn't solve every single edge case. So please like this explainer and make sure you're subscribed to the channel so you don't miss part 2, where we're going to tackle the execution dangers of agentic tools, those scenarios where the AI isn't just suggesting code but actually running it. I'll leave you with this final, slightly provocative thought. If the AI is writing the code and the AI is testing the code, who is actually building the software? Think about it, keep your code base clean, and I'll catch you in the next one.